Hello everybody, welcome to Traditional Technology Solutions. This is Santana Krishnan presenting you about organic paddy cultivation method. You can contact me through email pancreas@tts.org.in. What is organic farming? Let's see the standard definition provided by USDA regarding organic farming. Organic farming is a system which avoids or largely excludes the use of synthetic inputs such as fertilizers, pesticides, hormones, feed additives, etc., and to maximum extent feasibly rely upon crop rotation, crop residues, animal manures, off-farm organic waste, mineral-grade rock additives, and biological system of nutrition mobilization and plant protection. Why do we need organic farming? Organic farming method doesn't pollute the environment. It gives good quality of non-toxic products. In this method, the investment required for the production reduces and the yield increases by time. Advantages and disadvantages of organic farming. Let's see what are the advantages. First, the consumer benefits. Let's see the nutrition value in organic farming. The nutrition value of the food is largely a function of its vitamins and mineral content. In this regard, organically grown food is comparatively superior in mineral content and that grown by modern conventional methods. Because it protects the life of the soil, organic farming reaps the benefits of soil life. It greatly facilitates plants to access soil nutrition. Healthy plants means healthy people, and such better nourished plants provide better nourishment to people and animal alike. The second important point is poison free. A major benefit to consumer of organic food is that it is free of contamination with health harming chemicals such as pesticides, fungicides, and herbicides. As you would know, expert of population fed on chemically grown foods, there has been a profound upward trend in the incidence of diseases associated with the exposure to toxic chemicals in the industrial societies. Take cancer, for example. Representative data on number of new cancer cases in New South Wales, Australia has been collected by New South Wales Federal Cancer Registry, and it proves the current scenario. Organically grown food tastes better than that of conventionally grown. The taste of the food and the vegetables is directly related to its sugar content, in which turn is a function of quality of nutrition that the plant itself has enjoyed. The third important point is food keeps longer. Organically grown plants are nourished naturally, rendering the structure and metabolic integrity of their cellular structure superior to those conventionally grown. As a result, organic grown foods can be stored longer and do not show the later susceptibility to rapid mold and rotting. The another part is of the benefit is the grower's benefit. When it comes to first for disease and pest resistance, a healthy plant grown organically in proper balanced soil resists most of the disease and pests. The weed competitiveness. Weeds are nature's band-aids placed by the wisdom of creation to heal and restore damaged soils. When farmer maintains the life of the soil, as they do in organic agriculture, the improved conditions dissuade many weeds and favor the crops. The crops being healthier and are better able to compete with those weeds that are present. Drought resistance. Organically grown food plants are more drought tolerant. This was my own experience, which I am going to share with you the following discussion. Because chemical fertilizer is soluble, plants are forced to imbibe it every time. They are thirsty for water. They can enjoy good growth as long as water is readily available. As soon as water becomes limited, however, the soluble nutrition salts in the cells of the chemically fed plants are unable to osmotically draw sufficient water to maintain safe dilution. They soon reach toxic concentration and the plant stops growing, pays off, and dies earlier than it was otherwise would have. Added value. There is a distinct market of consumers who recognize the greater food value of organic produce and they are willing to pay premium prices to it due to the following reasons. People started to be nutritious conscious and want to consume good quality, tasty, and nutritious food. Consumer got awakened by the increase in medical expense and it causes the factor in food. Example, pesticides and herbicides added to food. Hence, they are willing to spend on safe food and water than to organic food have become the need of the time and there is a good requirement of it continuously in future. Lower input cost. By definition, organic farming does not incur the use of expensive agri-chemicals. They are not permitted. The greater resistance of their crops to pests and the diseases save farmers significantly in expensive insecticides, fungicides, and other pesticides. Fertilizers are either created in-site by green manuring and leguminous crop rotation or on farm via composting and worm farming. Biodynamic farmers are used a low-cost microbial solutions sprayed onto their crops. Bringing back the nature's undisturbed nitrogen cycle costs a bit more effort, however, reap benefits to production at minimal maintenance. The crops are healthy enough to compete with the weeds and it reduces extensive weeding costs. In organic farming, large amount of good bacteria, fungus, earthworms present in the soil keeps the soil soft and biologically active. The higher carbon content in the soil leads to easy maintenance of the soil quality, hence cost of mechanical tilling for loosening the soil reduces. Organic farming limits. Let's see the limitations of organic farming. Productivity. When it comes to productivity, proponents of industrialized agriculture point to its superior productivity. In short term, this yield is possible by expending massive inputs of chemicals and machinery, working over land field of single crop, that is monoculture. However, over long time frame, productivity advantage dwindle. Industrialized agriculture trashes the land and diminishes its soil life to the point where it can no longer function to convert available organic matter into soil fertility. Productivity begins to wane and attempts to bolster it with increasing chemical inputs as a similar effect to flogging a dead horse. Organic farming relies on living soil to build fertility. Absorption of nutrition to soil by composting of organic things take time compared to chemical fertilizers. The benefit of organic farming for soil life is fundamental to its methods. Applying chemical fertilizers to plant are like machine feeding of pre-digested fast food and nutritional supplement to humans, whereas applying organic fertilizers to plant are like mother cooking and feeding tasty fruits, vegetables and cereals to child. Organic matters are cooked and fed by bacteria, fungus, plant roots. Organic farming benefits food production without destroying our environmental resources, ensuring sustainability for not only the current but also future generations. Cultivation. While their conventional counterparts may sow by direct drilling of seed into the herbicide treated soils, organic farmers usually at least partially depend on cultivation to remove weeds prior to sowing. In contrast to cultivation, direct drilling does not mechanically disturb soil structure and removes the risk of exposed soil being being lost to wind or water erosion. This is a valued argument where farmers are working in marginal quality soils. However, the structure of agrochemically threatened soil is weakened by the corresponding loss of soil life and thus unable to maintain its integrity under occasional cultivation. Structurally sound, that is, soil which is rich in life, may be cultivated regularly without significant damage, particularly if protected appropriately by windbreaks and key line soil conservation methods. Even the need to cultivate may be questioned after noticing rice thriving wild along the weeds of roadsides. Japanese alternative agriculturist Masambu Fukuoka succeeded in establishing crops by broadcasting seed potted in clay onto untilled land. Genetically modified foods, GM crops, in short. Organically grown growers do not use genetically modified or re-engineered food crops, some of which are engineered to tolerate herbicides. Example, Roundup Ready canola, or resist pests. Example, bollworm resistant cotton. Conventional growers, on the other hand, are free to take advantage of GM crops. According to report from Directorate General of Agriculture of European Commission, productivity gains attributed to GM crops are usually negligible. When growing conditions like farmer experience and soil types are factored in, GM crops are often negative. The main advantage farmers using such crops is convenience only. There are worrying indications that GM crops may be associated with harm to both human health and environment. The main concern is that once they are released, it's highly impossible to unrelease them. Time. Indeed, organic farming requires greatly interaction between a farmer and his crop for observation, timely intervention and weed control. It is inherently more labor intensive than chemical or mechanical agriculture, so that naturally a single farmer can produce more crops using industrial methods than he or she could be used by using solely organic farming methods. Skill. It requires considerably more skill to farm organically. However, because professional farming of any sort naturally imparts a close and observant relationship to living things, the best organic farmers are converted agri-chemical farmers. Organic farmers do not have some convenient chemical fix on shelf for every problem they encounter. They have to engage carefully, observation and greater understanding in order to know how to tweak their farming system to correct the cause of the problem rather than simply putting a plaster over it. Environmental effects on organic farming. It's climate friendly. The synthetic inputs upon which conventional agriculture is so dependent are energy expensive to mine and manufacture. Today, the embodied energy of the industrial agriculture uses up to 9 calories for every 1 calorie of food that is produced. Organic agriculture, with its low input needs of our naturally derived substances, produces less greenhouse gas emissions and is considerably more climate friendly, ecologically friendly. It doesn't use soluble fertilizers. Farmers pour tons of phosphate and nitrogenous fertilizers on the cropping land every year. Because it is soluble, much of the fertilizer is either washed off the soil surface and into waterways, especially the phosphates, or leaches through the soil profile beyond the reach of plants and finds its way less directly into waterways, especially nitrates. Nitrate contamination of groundwater in many areas by concentration is greater than 50 mg per liter as nitrate form, resulting in groundwater that is unfit for drinking. With freshwater reserves under increasing pressure from climate change, it is a grave situation for humanity. The soluble nutrition pollution that contaminates surface water fuels the overgrowth of algae. What was not used by algae in freshwater waste flew out into ocean where it supports the growth of algae and sea plants and coral reef systems. These block access to sunlight, causing whatever its smoothest to die. It doesn't use pesticides or herbicides. Another pollution disaster caused by agricultural chemical use is the contamination of groundwater reserves with poisonous pesticides and herbicides like atrazine, simrazine, dieldrin, chlorpyrifos, amritrol, methoclatrol, trifluorine, diuron, dieldrin, lindane, and alacholol. While systematic monitoring of pesticide contamination of groundwater in Australia is limited, available tests have detected pesticides at least 20% of samples, indicating significant contamination, provided by Australia State Environmental Report 2001. Groundwater studies in the US have found similarly significant contamination in Carolina. For example, over 27% of wells sampled in 1997 were found to be contaminated with pesticides predominantly from routine agricultural use. There is no economical viable method to clean up widespread contamination. Pesticide contamination poses a serious, unreasonable public health threat to current and future groundwater. Synthetic agri-chemicals are mostly petrochemicals and thus a source of endocrine disturbing chemicals in the environment, especially when it comes for xenoestrogens. There is also evidence to link xenoestrogens to a range of human medical concerns, particularly reproductive problems such as reduced sperm count in men and breast cancer in women. Even the safest herbicides such as Roundup, which is known as glycophosphate, the second most widely used in USA, are now known to pose danger to wetland ecologies and can totally decimate frog populations at routine contamination levels. We got these valuable details from the website www.smallfarmpermacultureandsustainableliving.com. We thank them for giving useful points regarding organic farming. Let's see another problem due to frog population. When it comes for reduction in frog population, we practically see the population of mosquitoes are increased since mosquito larvae are not consumed by frogs. How do we do organic farming? It is done by proper linking of natural nitrogen cycle such that the lost nutrition of the soil are fed back and the microbial nutritional fertility is maintained. Here we shall discuss about organic paddy farming method. Paddy growing in organic farming. Why paddy? Rice is the most widely consumed staple food for a large part of world's human population, especially in Asia. It is gained that third highest worldwide production after sugarcane and maize, according to data of FAO STAT 2012. Rice is the most important grain with regard to human nutrition and calorific intake, providing more than one-fifth of the calories consumed worldwide by humans. Here we shall choose to grow rice in organic farming method with traditional seeds in order to make the major part of food to be healthy and nutritious. Why traditionally used seeds are preferred? Usage of traditional seeds have the following advantages. They are produced by natural evolution according to the soil and climate of the place. Hence, they adapt easily and grow well. They are more resistant to effects of climate changes of the place and are immune to pests and diseases. Hence, pesticides are not much required. There exist different varieties of seeds of same crop, which can be sown according to the season, soil type, water availability, investment power of the farmer, profitability, medicinal and household requirements. Traditional seeds doesn't require large quantities of manure, water and maintenance. The taste and nutritional properties of food is good. Traditional seeds have good medicinal properties based on the type and they can be consumed according to the physical condition of the consumer. Here we shall discuss about paddy growing in monocropping, that is single crop in field method. In this method, the soil can be enriched by adding a combination of green manure, cow dung, fermented fruit and vegetable waste, and also by addition of various paddy-friendly microorganisms. The place of paddy field in which we did organic paddy farming is situated in the following area. The name of the village is Neyadupakam. It is situated in Uttarameru Taluk of Kanjipuram district. It is inside Tamil Nadu state in India. We have selected 3 acres of barren land which was not in use for past 5 years. This is to minimize the residual chemical levels used in previous cultivation. Soil testing was done for 5 land samples according to the standard procedure and the test reports were obtained from government soil testing lab. The result of soil testing. From the test results, we came to know the mineral and trace elemental status of the soil. We also came to know the amount of chemical fertilizers that has to be added to improve the yield. But we are highly advised by the lab authorities and to add 5 tons of green manure of different crops to get better yields than chemical fertilizers. Since our aim is to do organic farming, we opted to grow green manure crops. Let's have a step-by-step illustration of how we did organic paddy cultivation. The land got irrigated at one side. Irrigation pipes were buried to the other parts of the land. We laid pipelines about 400 feet in order to irrigate the other parts of the land. Rest of the parts of the land also got irrigated. Land was plowed after irrigation. Green fodder seeds of multiple crops were mixed and spread all over the lands. Multiple crops have ability to absorb multiple nutrients from soil and atmosphere. Hence, when they get pressed back to the soil, they provide multiple nutrients to it. Seeds of multiple crops were germinated. Crops grown to the height of 2 feet tall in 2 months after sowing. Crops grown to a height of 5 feet tall at the end of third month. The crops were tested and buried back to the soil by tractor before they started to blossom. Soil was left irrigated for 15 days to aid proper composting of leaves. In this process, the mulched parts of the plants become food for the soil microbes and get converted to composted manure for upcoming plants. Composting process generates heat. Hence, the cultivation process has to be started after cooling of the soil. WAM is also called as vesicular avascular mycorrhizae. Was mixed with the dry sand. WAM is a fungus which binds to the plant roots and helps them to absorb nutrition from the soil easily. WAM mixture was sprinkled over the land. the land got puddled and leveled such that worm can reach the root depth. Phosphobacteria and Azospirillum were mixed with neem seed powder and sprinkled uniformly over land. Phosphobacteria increases the phosphorus intake of plant by converting insoluble phosphorus to its absorbable form. Azospirillum absorbs nitrogen from atmosphere and fix them in soil. Whereas neem seed powder provides good immunity to root from diseases and prevent insect attack. Traditional variety of South Indian rice were purchased from a private organization known as CIK. It is also abbreviated as Center for Indian Knowledge Systems. The name of the rice is pullakar. It is used to make famous South Indian breakfast called idli and dosa. Let's see the properties of the pullakar rice. Pullakar is a short duration red rice cultivated in summer season. The crop is highly drought, pest and disease resistant, and locally the star is preferred for roofing material. Medicinal properties are also attributed to this rice include revitalizing and energizing the body, lowering bad cholesterol levels, controlling blood sugar levels. Red rice varieties have antioxidant properties and have good higher content of zinc and iron than white rice. We have practically experienced a feeling of lightness in stomach and freshness in work even after having a bit heavy breakfast made from this rice. Let's see the properties provided by Wikipedia regarding pullakar rice. Pullakar rice is an interesting ancient variety grown primarily in India with lot of health benefits. It's one of the red rice varieties grown in India. It possesses antioxidant properties and has higher zinc content and iron content than white rice. They also strengthen, regenerate and energize the body, regulate blood pressure and prevent skin disease and premature aging. Pullakar rice contains complex carbohydrates that are good for health. It is known that flavonoid and anthocyanin components are closely related to antioxidant properties of black rice. Okay, it all found that the DPPH radical scavenging activity is higher in red rices than in black and white rices, and that is actively is correlated with polyphenols and proanthocyanin content. Considering that the highest scavenging activity due to presence of polyphenols is in red rices than in black and white rices, red rices could once again find favor with health conscious consumers. The rice is suitable for making idli and dosa and porridge. Let's see how we prepare the seedling. CIKS provided us good quality seeds which has passed the germination test. We soaked the seeds overnight by immersing them in antifungal solution. The seeds were placed inside a gunny bag and the bag was loosely tied such that it can expand easily in the bag when soaked up. The antifungal solution consisted of local native cow's urine, about 200 ml, Trichoderma viridi 50 ml, Pseudomonas 50 ml in 10 liters of tap water. The seeds were kept in shaded floor during daytime to drain excess water and soaked again in fresh solution next time. The third day, the seed got sprouted up and the remaining solution was mixed in the irrigation water. 2 days after germination, the seeds were distributed over prepared land and got covered by straw to maintain moisture. For comparison, we have grown sapling in wetland and HDPE mat. Let's see the rice sampling grown in a separate place. After 12 days, the saplings were transported to place of plantation. Samplings grown on land were better than that on mat in hot summer climate. Samplings got planted in straight line as per SRA of plantation method using marked rope. SRA is abbreviated as System of Rice Intensification. Rest of the land also got planted with rice samplings. The row-to-row spacing between plantation was maintained around 25 centimeters. You can see the growth of the saplings after 10 days from transplantation. 15 days after transplantation. At this time, we got into trouble. The irrigation got stopped due to acute water shortage. 20 days after transplantation, you can see the growth of the crop without water. 30 days after transplantation, still not irrigated. After 25 days, we rinsed our bore well with pneumatic compressor and got water by lowering the submersible pump from an initial depth of 82 feet to 98 feet. 40 days after transplantation, paddy got irrigated after 26 days, but the growth didn't affect. Here, kindly note that due to organic farming process, the paddy withstood 25 days of drought and kept even growing. The green manure provided before transplantation stored enough moisture and released it slowly to paddy. This enabled the plant to withstand extreme hot and dry climate of the summer provided in our village. We also noticed paddy grown by chemical farming process at the same time in our village got dried up within 10 days of drought and turned like yellow straw. Weeding was done initially after 10 days of transplantation, but we noticed the crops were more stronger and healthier than the weeds. We noticed the gap between the plants reduced by time by bunching of new stems from a single plant. Since the sun's rays reached the ground, rodents didn't get good hiding place from the predators. Hence, damaged crops by rodents were prevented considerably. 50 days after transplantation, finally note the weeds are very less. Compost tea solutions were prepared and provided to paddy land. This solution is prepared by fermenting the following ingredients: waste portion of fruits and vegetables, cowhide, sour buttermilk, 2 handfuls of land soil, WAM, phosphobacteria, Trichoderma viridi, Pseudomonas, Azospirillum, and neem leaves for covering. The fermentation was covered by a layer of neem leaves in a cement pan. The fermentation took place for a month by different microbes present in the above said ingredients. Neem leaves provide a barrier for flies laying eggs in the compost solution. The solution got stirred every day to aid proper decomposing. This solution was mixed with irrigation water and it acted as a growth promoter. We noticed a rapid growth in the plant visible in 10 days. Finally, notice the rapid growth. After 60 days of transplantation, the plant got to the height of about 4 feet, which were suppressed by the crops. 70 days after transplantation, grains started to appear. As the grain started to appear more, the leaves turned into light yellow. Panicle with rice clusters reached a length over half a feet and tend to bend by grain weight. 80 days after transplantation, panicle with grains grown to a length of 1 feet. Grain started to mature and bend due to grain weight. 85 days after transplantation. 90 days after transplantation, grains got matured but off a green in color. Paddy got ripened by 100 days and ready for harvest. Paddy got harvested by a harvesting machine. The rice straw were collected for cattle feeding. Straw from organically cultivated paddy got piled up in our place for future cattle feeding. Heap of harvested rice. We got 900 kg of good quality rice grains per acre in the first harvest. Boiled and milled rice ready for consumption. Future programs and expectations. We expect more increase in quantity of rice in next harvest. Since we found a drastic improvement in quality of soil like softness, more number of earthworms and humus due to organic farming. We did manual harvesting in corners of land where harvesting machine can't reach and got 60 kg of rice. This rice will be used as rice seed for next plantation. We prefer manual harvesting for seed production because machine harvesting may break the germination tips of the rice. We got enough seeds for large area cultivation next time. We have also learned many new techniques to improve the rice production. We shall discuss about new varieties, multi-cropping, post-harvest processing and marketing strategies in the next subsequent presentations. Kindly wait for our next presentation, upcoming soon. Thank you for being with us. Have a nice day.